thank you very much for having me here. It's super humbling each time, super impressive. Plus I'm jet lagged, so I'm even more impressed. So we used to be a research group in a computer science lab in France, and we wanted to help with nanotechnology, but we knew nothing. So we decided that anyway it was too complicated for anybody or any group to do everything, because you have to be good in math, physics, biology, chemistry, computer science, high-performance computing, machine learning. It's crazy. So we took the hardcore computer science approach. We designed an open platform so that experts can integrate their expertise inside SAMSON. And the first version was released in 2015. And in 2018, we started a company as a spin-off of the research lab. And so now you can get SAMSON at samsonconnect.net. We have users over the world in thousands of labs. We have clients in over 30 countries. So it's pharmas, biotechs, research groups. The thing is, we want to be here on the long term to help with nanoscience, nanotechnology, advanced design, but we have to find a viable business path. So that's why we have a certain focus for now. But we make SAMSON general enough, so you can use SAMSON to do many, many things, to build things using interactive physics. You can assemble parts, you can add collections of parts yourself, you can distribute them, you can measure, edit, inspect. You can communicate, you can make images for publications, you can make animations. We have lots of inspirations from everywhere. And most of all, you can extend SAMSON with extensions that you find on SAMSON Connect as well. And so you have some, let's say, if you do drug design, you have some for protein ligand docking. If you want to do molecular dynamics simulation on the desktop, on the cloud, you use this extension. This one embeds ESMFold by Meta and AlphaFold. And we're working with NVIDIA to integrate OpenFold in BioNemo. So we have many extensions for materials, for bio. And so what I'm going to show you is might crash, because it's the version that's going to be released in a few days, we hope, with 3 main new things. So I'm just going to, sorry, I should have launched it while I was speaking. So maybe I can dig a bit into here. Yeah, you have some extensions, for example, for that's something we did in collaboration with CEA in France, like to analyze images produced by TMD instruments to reconstruct models based on microscope images, etc. You have modules for virtual reality, etc., etc. And you can do all these modules in C++. You get the free, there is a free version of SAMSON, a free SDK, and you can develop your own extensions in C++. What else? And on another place in the page, you have, sorry, it's going through my phone, so it's a bit slow to start. And on another place, you have a place where people can share documents that they've made with SAMSON, potentially parts or models that they do for their research. Okay, so the first thing I want to show is, so it's not yet out, but it's going to be, you know, scientists want to communicate, but they want to make nice images, and for that you can use SAMSON or Pymol camera. But some students, like a student you mentioned, Philip, are more advanced and use things like Blender. And so we wanted to make it easy for people who want to do things like Blender quality, to make it easy in SAMSON. So what we did is we integrated the renderer of Blender inside SAMSON so that you can activate it in a single click. So I have this model here provided by Tom Moore, but I don't know who did it originally. So it's provided by Tom Moore, who loves doing work in Blender. But what I can do is I just click here, and I activate the Blender renderer. And now I can change, I can zoom. So of course it depends on your machine, but it's like interactive path tracing for those who know that. And you can do very nice images like that in just one click in SAMSON, and you can control that. So I could say, well, I'm going to select this, maybe select this chain, make it a bit emissive, so that it emits light. Could turn this one. Where is this one? Okay, this one, let's turn it into glass. So you can do your images and movies like that. So that's one thing that we're going to release very soon. Sorry. Another thing we're releasing, let's deactivate the path tracer, is I told you that on the marketplace people can develop extensions in C++, but of course that's more difficult than doing Python. So we wanted to make it super easy for people to program in Python and distribute their apps in SAMSON. And so what we did is we are now shipping a Python interpreter and a possibility for users to embed any files inside SAMSON. So what we can do is just, let's say I load this one, and here I have a few molecules, so I could do interactive physics, add stuff and stuff. But if you see here, I have some files. I have a Python file and a PDF. So you can put really any type of files you want. So let's say you want to advertise your research. You're going to create a SAMSON document, put your papers, research notes, Python scripts, etc., even models. And I can double click here. I have a security pop-up, and it's going to open my PDF viewer. So that's a paper by Alexis, paper by Alexis here. And what I can do, so I can show you the script here. So we also embedded the code editor of Visual Studio Code, so the Monaco editor. So it's now integrated here. So you have this code editor, and in this little example, there is the creation of a little interface with a button, translate atom. And when I click on this button, it's calling this function. And this function is going to select all the nodes of types atoms, are going to translate it by 1 angstrom in the x direction. And I'm activating the undo system to make it undoable. And so now when I double click here on this app, the Python console is going to start, and it's creating this app. So you see that you can really create apps and make your documents computable, executable, and you send that to your colleagues who don't know how to program, and then they will easily modify, like run your app on different inputs, etc., etc. So if I click on that, it just translates the atoms, and in the history, I'm going to be able to undo this just because I had these two lines, a begin holding and end holding. So it's super easy to create apps, and we hope to do demos through discussions by integrating more advanced things like machine learning tools, etc., etc. But you have templates already to do analysis, construction, etc., etc. So that's the second thing, trying to make it as easy as possible to create apps and share them just by sending a document or even putting the document on GitHub potentially. And the last thing, because since everything is still a bit, 1 minute? Okay. So the last thing is we're adding SAMSON AI, so based on ChatGPT, but a type of augmented ChatGPT. And so what I'm going to do is I'm going to use the mic, because I'm lazy, to ask questions. Hey there. It's better to be polite in case they remember in the future. So I have the transcription, and I'm going to have a, I don't know, welcome message. Sorry again, it's going through my phone. So let's ask something a bit more complex. I would like to dock a ligand into a protein. How can I do that? And so I'm going to have an answer constructed based on the documentation of SAMSON and the documentation of the extensions. So the answer is really constructed for me, and I have direct links to the commands, a little summary of the help, and even links to documentation. And we can do that with any extension that you're going to add to the platform. But so the last thing I want to show is, of course, you can do so much more with language models. So the second way we augment ChatGPT inside SAMSON is by making it an agent and adding tools based on it. So what we do, for example, here, what I did is I Googled Alexis Courbet bioarchive, and I found this paper first, and I have a link to the PDF. So the PDF I open actually. So I'm going to copy the link address, and here I'm going to say, learn this address. Sorry. And so it's processing the PDF to be able to answer questions about this document, and I can put any number of documents like that, and this information is stored in your profile and remembered throughout sessions. So now it says learned. So now I can say refer. What is the optimization protocol? So I haven't read the paper, but I think just a bit, so I'm hoping that's a relevant question. So I say /refer to specifically ask it to refer to that paper that was in the document. And so here I have different steps, initialization, blah, blah, blah. So here it didn't specify to that, so let's ask it something more specific. Refer, how were crystals made? Oops. And you can add a bunch of papers like that, ask a typical ChatGPT task, like write a summary, condense, ask specific information, etc., etc. Another thing I could show, but let's do it offline, is like you have other commands like do. So you say, well, select this, add a Van der Waals visual model. So you see now you have all the details in some parts of the paper with a reference to the paper. And when I'm done, I say forget. Oops. And it's going. Sorry?
Does that free up tokens again? Can you go back and forward, or like the machine learning says, the LLMs? Like
so this is not learning in the sense of fine-tuning the model. It's learning in the sense of cutting everything into pieces, creating vector embeddings that are used to build the prompt that is used to answer the user question.
that's all local.
No, that's done in the cloud with our API that's based on OpenAI's API. Thank you. So that's it. Yeah, thank you.
Well, we already had one question. Another one? Comment?
In that wonderful example where you ask it, what are the steps in docking? Why not just cut out the human entirely and get it to do it itself? Why to do the steps itself?
So that's that's what I was saying. So if I say /do, so do, select all atoms, apply a Van der Waals model, and color everything in pink. Why not? So we'll see if it works. Again, it's going through my phone and stuff, so we'll see. Atoms. So normally it's going to try to decompose that into a crash. Okay, so that's the bed. Cut!
Okay, we have another question again.
At least we're a little bit away from world domination.
Exactly. Yeah, that's
Okay.
3.5.
After you conditioned on the paper, can you extract the protocol and have SAMSON generate basically the molecules that were mentioned in the protocol? I mean, that would be cool, right? Because otherwise, why would I use SAMSON? I can also use ChatGPT, just condition on the paper if I want to know something about the paper. But I want to generate structures.
I guess on ChatGPT you have some plugins that can do that. I don't know if they can work on multiple papers at the same time. Maybe. But yeah, you could imagine that you combine that with other tools and other steps in the pipeline. But that's really the first version, and we're very happy to discuss to see how you would like to use it, actually, and what you would like to add.
Okay, and for the original question that we always ask at the end of every talk, could be used for any.
Yeah, that's our goal. Our goal for now is to find clients that help us live a long time, so that then we have time to have people integrate more things, expert for DNA, STM, etc.
Wonderful. Thank you so much.
Sorry.